into the curriculum, let's see what we have to do here. It says replicate the motion graph of the position of the top of the follower above the box. Once again, those are keywords in this. Then draw a motion graph on the same grid to represent the radial dimension of the cam. This will require you to translate the follower motion graph down such that the radial dimension at the angle of rotation of 0 degrees is ½ an inch. So we have to remember, okay, that the radial dimension at the angle of 0, okay, has to be ½ an inch. Okay, so let's go ahead. Let's jump over into Excel. I've already given you some of the answers. I'm going to pull those off. So the height of the top of our cam at 0 degrees, they said had to be ½ an inch. Okay, so at this point in time, if we think about it, okay, we know that there is going to be a follower rod, okay, and the follower rod is going to be able to go up and down, okay, which means that this distance is always going to stay constant because there is going to be a connection between the follower rod and the actual cam. Okay, so with that being said, if we know that the height at the top of our cam is at 0.5 and the height at the top of the follower rod is 1.25, we can see that there is a difference in these two of 0.75. So what I'm going to do is write an equation. I'm going to say that B3 is going to be equal to C3 minus 0.75. I'm going to go ahead and hit enter. Once again, all we did on that one was we found out that the difference was 0.75, so we just took 1.375 minus 0.75 to give us this answer. Okay, in order to do that to all of them, I'm going to come up here and pick on the dot at the bottom right-hand corner of the cell. I'm going to go ahead and drag these down. You're going to see I just did that for angles 0 through 360, so we're going every 45 degrees. Okay, with that being done, I'm now going to go ahead and select everything I have in this chart. I'm going to go up to Insert. I'm now going to come over here to Scatter Plot, and I want this to be showing as a smooth line. Okay, so we can see the correlation between the top of the follower cam and the top of the cam itself. Okay, and now something that's actually kind of cool is we can get a preview of what that cam is going to look like. So I'm going to come back up here and go to Insert. I'm going to this time just select the height of the top of the cam. I'm now going to come over, I'm going to use a radar graph. I'm going to go ahead and pick the second option of the radar graph. I'm going to come down and take a look at it. And there we go. So obviously this is a little bit choppy, and the reason is, if anybody paid attention in Unit 3, is the fact that we don't have very much data as part of our data group. Now if we switch this to every 15 degrees, this would really smooth out and would look very, very close to what we're about ready to discover with the profile of the cam. Okay, so with that being said, I'm now going to need this information that we see here, okay, because what I'm going to be doing is I'm going to be using that polar graph that I showed you a little bit ago on how to download that. Students are then going to be taking this information that they see here and plotting this into the actual polar graph. So when I open, and I'm going to just take a look at it there, when students receive a sheet of this polar graph, what they have to do is they have to read this information and the height at the top of the cam, and they have to plug that in. So for example, it's saying at the 0 angle, the height of the top of my cam is at ½ an inch. So I would come in here, I found my 0 angle. I'm now going to be counting these up. So each one of these lines is worth 0.125. So I take 0.5 divided by 0.125. I get 1, 2, 3, 4 lines. And I'm going to go out there and plot the point. I'm now going to go on to the second one. So at 45 degrees, I look down here, we can see that distance is 0.625. If I took 0.625 divided by 0.125, I'm going to see that that's 1, 2, 3, 4, 5 lines. I'm going to go ahead and continue on with this and plot all the points, okay, all the way up to 360 degrees. Okay, then students are going to be coming out and they're going to be creating, okay, using a pencil, they're going to be going from point to point, and they're going to be sketching out the shape of their cam. Which is going to look like this. So just to show you, and one more, let's just increase the weight on this so you can see it. That is what their profile of their cam is going to look like. Now the disconnect for a lot of people is, okay, how do I take this now and incorporate this into Inventor? Okay, so once again, I'm going to have this data in front of me. Okay, I'm going to go over to Inventor.